Hey, good morning, grade 11s. Today we are going to continue with some practical work. Specifically, we're going to pick up where we've left after the first week of the term, continuing with arrays. Now, the reason why we're doing chapter 12 first, before we're doing 8, 9, 10, and 11, is because it's something that you're familiar with already, rather than doing something entirely new. So in chapter 7, we looked at what arrays are, how to declare them, how to populate values into arrays, either by using hard coding, adding values to each element of the array separately, to use loops, making use of constant arrays where we already declare values as part of the declaration of the array. So those are the basic things that we've covered. We've also looked at searching an array for a specific value. We are going to expand on that this week. So the main things that we're going to look at is sorting and searching arrays. There's two types of sortings that we're going to look at today and tomorrow. The first one is the selection sort, and tomorrow we will look at the bubble sort. Now, these two ways of sorting an array are basically the same in the sense of the results that it produces an array that is sorted either from smallest to largest or in alphabetical and ascending or descending order. Now, the selection sort uses a different algorithm than the bubble sort. In the end, it doesn't really matter which one you are familiarizing yourself with. I will, in an exam or test, you will simply be asked to sort the array, and you can you can choose whether that is the selection sort or the bubble sort. Now, it's very difficult for you to imagine now which one you're going to choose. So let's cover selection sort today and bubble sort tomorrow, and by the end of tomorrow's lesson, you will be able to make a choice which one you would prefer. And then we are also going to look at searching through specifically sorted arrays. Now, we had a linear search already in chapter 7, where we found the position of a specific value. But I'm going to introduce you to something that we call a binary search as well, which will speed up the speed of finding an element specifically in a sorted array. And then we will also look at sorting arrays where we have parallel arrays. That is, for example, you have a text file with authors and their book titles. And as you extract the data from the text files and you write it into an array, you have two arrays, one for the author, one for the book title. Now, they are linked, they are parallel. So in position 1, you have the author of book 1, and in the second array, you have the title of of book 1. And book 2, the author is in second position as well as the title. Now, if you sort the author array alphabetically, it might change the order of the authors. But now, if we do not sort the second array in the same way, the books will be scrambled up. So I will show you how to use an algorithm to sort both arrays simultaneously. All right. I think that's enough for an introduction. I will bring up the textbook. There we go. So, chapter 12, page 248. So, the idea is to sort elements in an array either alphabetical order or from smallest to largest or from largest to smallest. Now, very important to know is that in Delphi or in programming generally, that letters are actually ASCII values. So hence a small a, which is a number 97, is larger than a capital A, which has the value of 65. So if we want to search or sort something in alphabetical order, we have to make sure that, you know, all the values in them is either capital or lowercase, so that we can have a true, you know, comparison between the two values. So we can use functions like uppercase or lowercase to do that. But we will look at that when we do the look at the algorithm. So just know that Adam in small with a small letter is not equal to Adam, which is capital. So if I would sort this alphabetical, Adam will be larger than Adam, if that makes sense. All right. So Adam, small letters, is bigger than Adam, all capital letters. Sorry, I'm highlighting now things, so let me take that off. Right, now I can scroll again. So Adam is bigger. No, it's not bigger. Adam is smaller than Alf because A is the same, but the second letter now is smaller. So that's true. Adam is smaller than Evelina. That is true. So it's not according to the number of characters in the word, but it takes it from position 1, and then it looks at the second one and the third one, etc. So Evelina, because it has an E, which is larger than A, so this one is true. Adam is bigger than Abe. That is true, because the D is bigger than the B. And ABC is bigger than AB, which is true because the C is bigger than nothing. Right, so knowing that, we can now look at our algorithm for our selection sort. All right. So the first name element in the array is compared to the second name. So we have here now a list: Zorro, Pamela, Yanis, and Mary. You can see this is not sorted alphabetically. The first name is greater than the second name. So Zorro is bigger than Pamela because Z is bigger than P. The two names change places. So we're comparing this. If this is bigger than that, then we have to swap places. The first name is then compared to the second one. So this one to the third one, sorry, Pamela. So because they've swapped, we are now comparing the first one to this one. If they wouldn't have had swapped, we would have had still Zorro in the first place. So in this way, in the end, we will end up with the smallest one in the first position. At the end of the first circle, the smallest name will be in the first position of the array. So in this case, Zorro is compared to Pamela. They are now swapped around because Zorro is bigger than Pamela. So Pamela is now in the first position. We're going to check that with Yanis. Giannis is bigger or smaller than Pamela, so they are swapped around. And then Giannis is compared to the last one, Mary, and Giannis is smaller than Mary, so they do not swap. Now we would repeat this. So we've compared now the first one to the second, the first one to the third, the first one to the last. Now we go to the second one, and we would now, which is Zorro in this case, we would compare Zorro with Pamela. And Pamela is smaller than Zorro, so we will swap them around. Now we compare Pamela to Mary, and we'll see that Pamela is larger than Mary, so we will swap them around. So now the second largest or smallest letter is in the second position. Now we have Zorro and Pamela. Zorro is bigger, so we swap them around, and by the third time around, this loop, we will have them in alphabetical order. So they are then repeated. So the algorithm looks as follows. For k, 1 to number of elements minus 1. For L, k plus 1 to the number of elements. So we have a nested for loop with k 1 to the number of elements minus 1, so until the second last. And the other second loop is from k plus 1 to the end. Why do we do this? Because we have to compare two adjacent elements with each other. Very, very important that for L, we make use of k in this for loop. Why? Because as this increases, we want always the next biggest. Because if we're done with 1, we are done with 1. We know 1 is the smallest element in the array. Then we move on to 2, and then we have to select 2, and we go all the way to the end. And we do that until k is the second last one, so that we can compare it with the last one. Okay, so if the element k is bigger than element L, then we swap these two around. So now this obviously is pseudocode. We will actually have to look at the code, and we'll do this just now. Activity 1, you know what? Ignore that. Okay, so here's our algorithm then. So we have an array from 1 to 100 of type string, and we declare our two loop variables, and we have a temporary, a container that we can keep one of the strings in case a swap needs to take place. So, as said in the pseudocode, we have k, 1 to a number of elements minus 1, and we have a nested loop for L, k plus 1 to a number of elements. Begin. If element k is bigger than element L, then skeep is r names k, r names k becomes r names L, and r names L is skeep. So we swap them around, and we have an end for L, and now this is repeated. So remember, with a nested loop, the inner loop is completed before it goes out of the loop, and then it finishes, the outer loop. But for every time it increases, it completes the entire inner loop, and then it goes to the outer loop until it is completed as well. And then we have end for L and end for K, and the result will be a sorted array. Now, what I need you to do today is activity 2. You're going to write a Delphi program which will read 10 numbers into an array and display the numbers in ascending order. All those files are available to you. They've been created for you already. And then in activity 2.2, you will just expand this program. Not a lot. They're already giving you some form of code here. I'm just going to highlight this. If you are going to use an array as part of your declaration of the array, you have to declare that as type, and this is done right on top under the user section, and then you can write these procedures within your private section of the form. All right, give it a shot. If you have any questions, please let me know, and then I will try to help you. So remember to like this video, subscribe to my channel, leave a positive comment. You guys rock.